Greetings and a very warm welcome. Tonight we are going to venture far away from the predictable and cosy domain underneath our feet, stepping out into one of the most magnificent, deeply soothing riddles that the universe has ever presented to humankind. Out there, floating silently in the heavy shadows that stretch between the stars, entirely different worlds are executing steady circles around distant suns. Freezing planetary moons safely conceal vast, liquid oceans beneath colossal sheets of ice, and bizarre alien signals cross the massive sky without offering any straightforward solution. A few of these alien environments might happen to possess the absolute perfect atmospheric conditions, the precise chemical blends, or the ideal thermal warmth required for biological life to initially ignite. Other worlds may quietly protect fascinating secrets, indicating that primitive organisms have already awakened somewhere out in the immense distance. As you sit back, relax, and permit yourself to slowly settle into a state of total comfort, let your active mind drift completely free across these peaceful thoughts. Tonight, there is absolutely no stress, no urgent rush to arrive anywhere, and no demanding challenges that require your immediate solution. There is only the vast, gentle quiet of the night sky, and the beautiful, reassuring realization that we belong to a reality that is far more expansive, vastly more wondrous, and considerably more magnificent than anything we normally observe in our day-to-day lives. Let us begin our journey by pausing to quietly consider our own solar system, a small celestial family drifting together through the dark. For a remarkably long period of time, human beings firmly believed that our unique planetary home was the absolute center of everything in existence. We naturally assumed that the brilliant sun, our bright silvery moon, and the glittering stars were all executing their daily movements purely for our benefit, serving as nothing more than a scenic background for the unfolding history of humanity. However, as the generations slowly passed and our scientific instruments grew increasingly advanced, we began to uncover a far more humbling and beautiful reality. We gradually learned that we are actually living on a tiny, fragile oasis of life, a beautiful blue marble spinning softly in a truly immense, nearly limitless cosmic ocean. Yet, despite our tiny physical size when measured against the staggering scale of the cosmos, human beings possess an incredibly powerful, unstoppable gift: our deep sense of curiosity. We have never been content to simply sit on our world and look out at the stars without asking questions. Instead, we have continuously built massive telescopes to extend our vision across the light years, and we have constructed highly advanced robotic explorers to cross the freezing voids of space on our behalf. These robotic scouts serve as our remote eyes and hands out in the dark, travelling to places that are far too distant or dangerous for human bodies to visit, and continuously sending back a treasure trove of groundbreaking data that completely reshapes our understanding of reality. When we use these advanced instruments to study our neighbouring planets, we instantly realize that even our local solar system is packed with an incredible diversity of environments. Just a short cosmic distance away from us sits the planet Mars, a cold desert world covered in rusty red dust and ancient dried-up riverbeds that hint at a much warmer, wetter past. Further out, past the rocky debris of the asteroid belt, rule the giant gas worlds Jupiter with its swirling, colourful bands of high-speed clouds and centuries-old storms, and Saturn, adorned with its magnificent shimmering rings made of billions of individual ice particles and space dust. Yet, as fascinating as these large planets truly are, some of the absolute most exciting and peaceful discoveries of recent times have occurred on the miniature worlds orbiting around them. For a long time, astronomers largely ignored the small moons of the outer solar system, assuming they were nothing more than dead, frozen chunks of rock floating uselessly in the deep freeze of space. But as our space probes finally executed close flybys of these distant objects, they captured images that completely shocked the scientific world, revealing dynamic, active landscapes that challenge our basic ideas of where life can survive. Consider the moon Europa, a fascinating world that circles the giant planet Jupiter. From the outside, Europa looks like a giant, smooth billiard ball covered in a highly complex network of dark, crisscrossing fractures. Its entire surface is made of solid water ice, frozen completely hard by the extreme temperatures of the outer solar system. Because it sits so incredibly far away from the warmth of the sun, you would naturally assume that Europa is a completely dead, frozen wasteland throughout. However, the data gathered by our space probes indicates that a completely different reality is hidden beneath that icy crust. As Europa executes its oblong orbit around Jupiter, the immense gravitational pull of the giant planet constantly tugs on the moon's interior structure. This persistent gravitational squeezing creates a massive amount of internal friction and heat, a process known as tidal heating. This internal warmth is so powerful that it completely melts the lower layers of the moon's ice sheet, creating a massive global ocean of liquid water that sits completely hidden beneath the frozen exterior. Scientists calculate that this hidden ocean could easily be over 60 miles deep, meaning that this tiny moon actually holds more liquid water than all of the oceans on Earth combined. Imagine floating in that dark subsurface sea, completely shielded from the harsh radiation of open space by a protective blanket of ice that is miles thick. Down in those pitch-black depths, there is no sunlight to drive photosynthesis, but life would not need the sun to survive. On the rocky floor of Europa's ocean, the moon's hot interior likely fuels hydrothermal vents, cracking open the crust and spewing out warm mineral-rich water into the freezing sea. On Earth, similar deep-sea vents are absolutely teeming with highly complex ecosystems of bizarre creatures that thrive entirely independent of sunlight, utilizing the chemical energy of the vents to power their lives. It is entirely possible that a similar, peaceful ecosystem is actively flourishing right now in the hidden waters of Europa. A strikingly similar marvel can be found even further out in the solar system, orbiting the ringed planet Saturn. This is the tiny moon Enceladus, a spectacular world that is so brilliant and white it reflects nearly all of the sunlight that strikes it. Enceladus is also completely covered in a thick layer of pristine ice, but it possesses an even more dramatic display of activity than Europa. Around the moon's south polar region, our spacecraft discovered a series of massive fractures in the ice, beautifully nicknamed tiger stripes. Through these deep fractures, Enceladus actively vents its hidden ocean directly into the vacuum of space. The internal pressure forces massive plumes of water vapor, ice crystals, and organic molecules to shoot hundreds of miles above the moon's surface, creating a spectacular glistening fountain that continuously feeds one of Saturn's outer rings. When our robotic space explorer, the Cassini probe, deliberately flew directly through these erupting plumes, its onboard instruments detected the clear, undeniable chemical signatures of complex organic compounds, methane, carbon dioxide, and salts. This means that Enceladus does not just possess a liquid ocean, but it actively contains all of the fundamental chemical ingredients necessary for life as we know it to exist. As these wonderful discoveries continue to unfold within our own local neighborhood, they naturally force us to look even further out, expanding our horizons to contemplate the truly vast collection of stars that make up our galaxy. For centuries, the question of whether other stars possessed their own planets was a matter of pure philosophy and speculation. We could see thousands of stars twinkling in the night sky, but we had absolutely no way of knowing if they were lonely suns or if they escorted their own families of worlds through the void. That ancient uncertainty completely vanished in the mid-1990s, with the historic discovery of the very first planet orbiting a sun-like star outside of our solar system. This monumental breakthrough opened up a brand new era of astronomy, launching a highly sophisticated global hunt for what we now call exoplanets. Since that moment, our specialized space telescopes, such as the legendary Kepler mission, have systematically scanned the stars, uncovering a reality that surpasses even our wildest imaginations. We now confidently know that planets are not rare anomalies at all. In fact, they are an incredibly common natural consequence of star formation. The current data suggests that on average, every single star you see in the night sky possesses at least one planet orbiting around it. When you multiply that reality across the hundreds of billions of stars that form our home Milky Way galaxy, you realize that our universe is absolutely crowded with trillions of individual worlds, each possessing its own unique geography, atmospheric composition, and cosmic story. Among this immense collection of newly discovered exoplanets, scientists are particularly interested in finding worlds that sit within a highly specific orbital region known as the habitable zone, or more affectionately, the Goldilocks zone. This is the precise region around a star where the temperature is neither too hot nor too cold for liquid water to exist stably on a planet's surface. If a planet orbits too close to its host star, the intense heat will completely boil its oceans away into space. If it orbits too far out, the extreme cold will freeze its waters solid. But inside the Goldilocks zone, the conditions are just right for liquid water, the ultimate solvent for biological life, to flow freely across the landscape. Finding these temperate rocky worlds is an incredibly delicate task, because planets do not emit their own light. Compared to the brilliant radiance of their host stars, exoplanets are incredibly dim and tiny, making them almost impossible to see directly. To locate them, astronomers must utilize highly clever indirect detection methods. One of the most successful techniques is known as the transit method, which involves continuously monitoring a star's brightness with extreme precision. When an exoplanet's orbital path happens to line up perfectly with our view from Earth, the planet will periodically pass directly in front of its star, executing a miniature cosmic eclipse. As the planet transits the star's face, it physically blocks a tiny fraction of the starlight, causing the star's apparent brightness to temporarily drop by a fraction of a percent. By carefully measuring the exact depth and timing of these regular dips in brightness, scientists can accurately calculate the planet's physical size, how fast it is travelling, and exactly how far away it orbits from its sun. Even more miraculously, this simple dip in starlight allows us to analyse the chemical composition of the planet's atmosphere from light years away. As the host star's light streams through the thin envelope of air surrounding the transiting planet, the different chemical gases present in the atmosphere will absorb very specific, distinct wavelengths of light. By passing this filtered starlight through a specialized instrument called a spectrograph, astronomers can read the unique chemical barcode left behind by the planet's atmosphere. This allows us to search for crucial biosignatures, the clear atmospheric indicators of life such as oxygen, water vapor, methane, and carbon dioxide, completely transforming our ability to study these distant worlds. As we look across the galactic landscape, we discover that the most common type of star in the universe is completely different from our own bright yellow sun. Roughly 3/4 of all the stars in the Milky Way are miniature, cool stars known as red dwarfs. These red dwarf stars are significantly smaller and dimmer than our sun, emitting a much softer reddish light and burning through their nuclear fuel at an incredibly slow, deliberate pace. Because they are so conservative with their energy, a red dwarf star can continuously shine for trillions of years, providing an incredibly stable, long-duration source of warmth for any planets orbiting around them. This immense lifespan means that life on a red dwarf planet would have a truly vast timeline to slowly awaken, adapt, and evolve. While our own sun will expand and destroy the Earth in a few billion years, civilizations living around a red dwarf could theoretically thrive for eons, enjoying a peaceful, unchanging celestial backdrop that lasts far longer than the current age of the entire universe. This makes red dwarf systems some of the most promising and intriguing places to look for highly evolved ancient alien intelligences. One of the most spectacular examples of a red dwarf planetary system discovered to date is the famous TRAPPIST-1 system, located roughly 40 light-years away from Earth. This miniature solar system contains a collection of 7 separate rocky planets, all packed tightly into an orbital space that is smaller than the orbit of Mercury around our Sun. Because the central red dwarf star is so cool and small, its planets can orbit incredibly close to its surface without being scorched. Remarkably, 3 of these 7 worlds sit directly within the star's habitable zone, making TRAPPIST-1 one of the primary targets for our ongoing search for habitable exoplanets and alien life. Imagine standing on the surface of one of these TRAPPIST-1 worlds, looking up at a sky that feels completely alien yet deeply beautiful. Because the planets are clustered so tightly together, your neighbouring sister worlds would not look like tiny distant points of light as Mars and Venus do from Earth. Instead, they would appear as giant, detailed globes drifting across your sky, close enough that you could easily discern their swirling cloud patterns, continents, and oceans with the naked eye. The central red dwarf sun would hang immense and heavy on the horizon, bathing the entire landscape in a warm, permanent amber glow that never changes. This permanent lighting condition occurs because planets that orbit very close to a red dwarf star often experience a physical phenomenon known as tidal locking. Just as the Earth's gravitational pull has locked the Moon so that it only ever shows us one face, the intense gravity of a red dwarf star locks its closest planets into a synchronous rotation. This means the planet takes the exact same amount of time to rotate once on its axis as it does to complete a full orbit around its star. Consequently, one side of the world permanently faces the burning star in eternal daylight, while the opposite side faces away into a realm of permanent freezing night. At first glance, a tidally locked world might sound like a harsh, inhospitable place to live, split between a scorching desert and an icy wasteland. However, sophisticated climate models designed by atmospheric scientists indicate that these worlds can actually maintain incredibly stable, comfortable environments. The massive temperature difference between the day side and the night side drives a continuous global atmospheric circulation, acting like a giant natural air conditioner that carries heat away from the sunlit face and distributes it across the dark side. This global weather pattern creates a beautifully temperate, peaceful region right along the border where day meets night, an area known as the terminator line or the twilight zone. Along this permanent ribbon of twilight, the red dwarf sun sits forever pinned at the horizon, casting long, soft shadows across a landscape that exists in a state of eternal dusk. The temperature in this zone would be incredibly mild and constant, completely free from the regular disruptions of seasons or nights. It is an environment that could easily support massive, stable biomes where life could flourish in absolute peace. As we continue to contemplate the incredible diversity of these distant worlds, it becomes increasingly clear that our traditional Earth-centric ideas of habitability are far too restrictive. For a long time, we assumed that life could only exist on a planet that looked exactly like our own rocky world with blue oceans, white clouds, and a bright yellow sun. But the spectacular discoveries of hidden subsurface oceans on frozen moons and temperate twilight zones on red dwarf planets prove that the universe possesses an endless variety of ways to foster and protect the spark of life. The cosmos is a literal tapestry of possibilities, a vast dark canvas where the laws of chemistry and physics weave together to create a limitless assortment of worlds. As you allow your mind to drift across these magnificent ideas, let the heavy weight of your daily worries gently fall away into the vast, quiet, empty space between the stars. There is an incredible comfort in realizing how small our individual problems are when viewed against the majestic, peaceful backdrop of a universe filled with trillions of unseen worlds, all moving slowly and quietly through their endless orbits. Some of these alien worlds might possess water layers so immensely deep and heavy that the crushing pressure generated deep below their surfaces forms exotic, high-pressure ice structures. This dense and fascinating material essentially acts as an impenetrable physical barrier that seals the deep liquid ocean completely off from the solid rocky mantle that lies far underneath. When this happens, the crucial chemical interactions between water and warm rock are entirely prevented from taking place. This geological separation matters profoundly because, on our own home planet, the non-stop chemical feedback loops between the deep seafloor crust and the salty oceans play a vital role in regulating global chemistry and maintaining the long-term habitability of the biosphere. If you completely remove the continents and the shallow coastal zones, the entire fundamental character of a planet transforms into something completely unrecognizable. High-altitude atmospheric winds would race endlessly over uninterrupted global seas without ever striking a landmass to disrupt their flow. Superstorms could gather and grow over vast oceanic distances, completely unhindered by mountains or shores. Ultimately, the complex chemistry of the deep hidden ocean would exert total control over every single mechanism operating within that world. This realization forces astrobiologists to view water worlds with a distinct mix of intense scientific excitement and careful measured caution. Water is undeniably life's most celebrated and critical ingredient, so our initial human instinct is to assume that having more of it on a planet is always an automatically better scenario for biology to emerge. However, a world blanketed by too much liquid water may rapidly become an environment that behaves very differently from Earth, creating unique chemical roadblocks that are not always helpful to developing organisms. This delicate balance demonstrates that habitability is never a simple binary status that a planet either possesses or lacks. Instead, it is a highly complex, multi-dimensional spectrum that depends heavily on the precise arrangement of a planet's entire internal architecture. As we widen our exploration to consider the strange planets that circle other suns, we frequently encounter worlds that challenge our most basic definitions of stability. A particularly captivating example is found on tidally locked exoplanets that orbit tightly around small dim red dwarf stars. Because these planets are caught in an intense gravitational embrace with their host star, their rotation has slowed down until it perfectly matches their orbital period. This unique cosmic setup creates a permanent day side and a permanent night side on the planet. One half of the world must endure constant, unchanging starlight, while the opposite hemisphere sits frozen in a realm of endless, heavy darkness. At first glance, this extreme arrangement sounds like the absolute end of any realistic habitability. You naturally imagine a split landscape where one side is completely scorched and dry, while the other side is forever buried under thick glaciers of ice. Yet, when atmospheric scientists simulate these tidally locked worlds using highly sophisticated climate models, a beautifully complex and peaceful picture begins to emerge. The massive temperature difference between the sunlit hemisphere and the dark hemisphere acts as a giant planetary engine, driving a continuous global air circulation. Thick layers of atmosphere can efficiently absorb the intense thermal energy from the day side and carry it smoothly across to the dark side, creating a natural air conditioning system that prevents either side from reaching absolute unlivable extremes. This permanent global weather pattern creates a remarkably stable, temperate ribbon of habitability right along the border where light meets shadow. This area is known as the terminator line, or the twilight zone. Along this narrow ribbon, the red dwarf star sits permanently pinned at the horizon, casting soft amber light and long, unmoving shadows across a landscape that exists in a state of eternal dusk. The climate here would remain incredibly mild and unchanging, completely free from the regular disruptions of seasons, days, or nights. This permanent twilight environment could theoretically support massive, stable biomes where alien flora and fauna could adapt to a life of absolute constancy. Organisms living along the terminator would never need to hibernate for winter, migrate to escape changing seasons, or sleep to wait out the dark of night. Instead, the steady, unchanging stream of dim light would allow biological processes to run continuously, adapting to a unique pace of life that has no equivalent anywhere on our dynamically changing Earth. This fascinating realization proves that the universe possesses an endless variety of ways to foster and protect the delicate spark of life, utilizing environmental configurations that sound completely alien to our everyday human experiences. When we look honestly at the immense history of our own solar system, we must humbly recognize that the vast majority of life's long journey on Earth was entirely microbial. Tiny single-celled organisms ruled our planet completely on their own for billions of years long, before complex animals, vast forests, or human intelligence ever arrived on the scene. This long historical timeline strongly suggests that the very first life we successfully find elsewhere in the cosmos, if we ever manage to locate it at all, is far more likely to be microscopic rather than large or dramatic. It may form thin, sticky films on wet rocks, drift quietly inside deeply buried aquifers, or survive as sparse, slow-moving communities in incredibly harsh, radioactive environments. To human eyes expecting to see majestic alien beasts or advanced technological cities, such a discovery might seem almost disappointingly plain and simple at first glance. Yet, locating even the simplest alien microbe would easily stand as one of the single greatest scientific achievements in all of human history. A few tiny extraterrestrial cells would instantly provide definitive, undeniable proof that biology is not a unique accidental miracle reserved solely for the planet Earth. They would tell us with absolute certainty that the universe can regularly take ordinary chemistry and more than once successfully cross the profound threshold into living, evolving systems. The ultimate wonder of such a discovery does not lie in its physical size, its visual spectacle, or its complexity. It lies entirely in the magnificent crossing of that fundamental threshold between the non-living and the living. Even the humblest, most microscopic extraterrestrial cell would instantly change humanity's perspective on its place in the cosmos forever. This realization has led modern astrobiologists to expand their search by looking for life in environments that completely defy our traditional human standards of comfort. One of the most powerful guides we possess in this journey is the study of extremophiles, the incredibly resilient organisms on Earth that already thrive in places where scientists once believed biology was absolutely impossible. We have found hardy microbes living deep below the ocean floor inside solid rock, flourishing in highly acidic hot springs, surviving under the immense pressure of Antarctic glaciers, and crowding around toxic hydrothermal vents. These incredible creatures demonstrate that life is not easily boxed in by human definitions of habitability. They can feed directly on raw volcanic chemicals, endure crushing forces, and persist in absolute darkness with no reliance on sunlight at all. By studying these extreme Earth organisms, researchers can build much better models of how life might look and survive inside hidden extraterrestrial biospheres. A subsurface ocean of salty water tucked beneath miles of thick ice on Europa, a deeply buried muddy aquifer on the plains of Mars, or a chemically active rocky interior on a distant exoplanet could easily host thriving communities of organisms that look and behave exactly like Earth's extremophiles. The first true aliens we encounter will likely be humble, unyielding microbes thriving quietly where almost nobody once thought biology could possibly belong. This shift in perspective means that our current search for life is no longer just a hunt for planets that look like Earth, but a patient, systematic mapping of the endless ways that chemistry can adapt and survive across the wider universe. As we look across the vast distances of the galaxy, we must also consider the intriguing possibility that some advanced alien civilizations have moved far beyond simple biology, leaving behind signatures that are technological rather than organic. This branch of astronomy, known as the search for technosignatures, focuses on looking for the intentional or unintentional marks that an advanced society would inevitably leave on its environment. A highly developed civilization might produce narrowband radio signals that natural cosmic sources can rarely recreate, build immense megastructures around their stars to harvest energy, or pollute their planetary atmospheres with artificial light and distinct industrial chemicals. The idea that pollution could become our very first material evidence of intelligent life among the stars is a strange and slightly sobering thought for humanity. If a distant civilization utilizes large amounts of energy or manufactures complex synthetic materials, their activities will naturally release unique chemical compounds into their sky that would be incredibly difficult to explain through ordinary, non-living planetary geology. For example, scientists sometimes discuss looking for synthetic gases similar in spirit to industrial chlorofluorocarbons or refrigerants. If an astronomer reads the filtered starlight from a distant exoplanet and detects a significant amount of these complex manufactured molecules, it would serve as an undeniable indicator of active technology. This means that a civilization's industrial footprint could travel across vast light years of empty space, announcing its presence to the rest of the universe long after its initial radio transmissions have faded into background noise. However, hunting for these faint technological and biological signatures is an incredibly difficult game, because nature is exceptionally clever at mimicking the signs of life, and human interference is everywhere. The history of modern astronomy is filled with tantalizing moments when scientists thought they had finally located a genuine sign of alien intelligence, only for deeper analysis to reveal a natural, non-living explanation. Every single time a candidate signal or a potential biosignature collapses under closer scientific scrutiny, it is never a wasted effort or a failure. Instead, it serves as a critical, necessary rehearsal for the real thing. Science does not progress by avoiding errors, but by openly exposing them, studying them thoroughly, and continuously raising its standards of proof. Every unexplained signal and false alarm teaches astronomers exactly how not to fool themselves, refining our instruments and models so that when a true, undeniable discovery finally arrives, we will possess the absolute certainty required to recognize it. When we turn our scientific gaze back toward the rocky inner worlds of our local solar system, we find ourselves continuously drawn back to Mars. The rusty desert planet continues to tease human curiosity with its complex collection of organic chemistry, unexplained methane fluctuations, and deep, unresolved mysteries. This enduring intrigue is precisely what keeps the red planet at the very center of modern space exploration. Mars refuses to be classified easily, it is neither a completely alive world nor a thoroughly dead one in the way people used to comfortably think. Instead, it persistently hands us tantalizing pieces of physical evidence that feel incredibly meaningful without ever combining into a neat, final explanation. Our advanced surface rovers have meticulously mapped out ancient river channels, old lakebed sediments, and unique water-formed minerals that collectively prove the Martian surface was once heavily drenched in liquid water, closely resembling the early environment of Earth. Following those historical insights came the exciting discovery of organic molecules carefully locked away inside ancient mudstones, appearing alongside strange seasonal spikes of methane gas that seem to drift and change in concentration over time. On our own world, a surge of methane is typically generated by active biological life, but it can also be produced through purely geological processes like the interaction of warm water and underground rock. This deep, persistent ambiguity is exactly why Mars remains so profoundly captivating to human beings. Every new clue we uncover seems to open up two entirely separate paths of interpretation at the exact same time. One pathway guides our imagination directly toward alien biology surviving underground, while the alternate route points toward highly unusual chemical processes occurring on a dying world that used to be vastly more welcoming to life than it is right now. Mars does not fascinate us because it has solved the ultimate question of existence. It fascinates us because it firmly refuses to let the cosmic mystery fade away. This realization means that our global hunt for extraterrestrial life has expanded dramatically to include the detection of advanced technology alongside primitive biology. This conceptual shift widens the entire human narrative in a genuinely thrilling direction. Modern scientists are no longer just asking whether simple microbes might be clinging to life under the frozen soils of a distant world. They are also actively asking whether intelligent civilizations might leave massive, undeniable marks on their home planets, out in the open void of space, or etched across the deep night sky. An advanced society might generate highly focused, narrow-band radio signals that natural cosmic objects like stars and quasars are physically unable to produce. They might construct colossal orbital megastructures to trap and harvest the total energy output of their stars, or pollute their worlds with bright artificial light, complex synthetic chemicals, and noticeable excess heat generated by immense industrial activities. To put it another way, it may be entirely possible for us to detect not just the presence of simple life, but the deliberate, organized activity of an intelligence acting with clear intention. This grand concept injects an entirely different emotional and intellectual energy into modern astronomy. Simple biology can easily saturate an alien planet with a quiet, hidden abundance of life, but advanced technology can profoundly alter an entire world in ways that travel effortlessly across vast interstellar distances. Of course, hunting for these faint artificial markers is an exceptionally difficult and delicate game, because nature is incredibly clever at mimicking patterns, and human electronic interference is constantly cluttering our data. Yet, the search remains profoundly important, because it embraces an incredibly bold, breathtaking possibility. Somewhere out there among the stars, an intelligent civilization may have already modified its local environment so completely that the structure of the universe itself has become their cosmic message board. As we look back at the history of this technological search, one highly unusual radio event captured in the summer of 1977 continues to fascinate the scientific community. For a single, fleeting moment, a remarkably powerful and tightly focused narrow-band radio signal registered on the data charts of an Ohio radio telescope. The burst of energy was so intensely strong, so uniquely clean, and so utterly different from ordinary cosmic background noise that an observing astronomer completely stunned by what he saw on the printout, immediately circled the data with his pen and wrote one unforgettable word right beside it. Wow. After those 72 seconds of intense transmission, the signal completely vanished into the quiet void. It was never successfully located again, it never repeated itself on command for confirmation, and it has never been explained in a way that completely satisfies the scientific community. This is precisely why the memory of that moment lingers so deeply in our minds. The unique signal possessed very specific physical qualities that made researchers dream of an intentional alien broadcast rather than a routine, natural space phenomenon. Yet science is built on caution and skepticism for a very good reason. A single, isolated event can never serve as definitive proof. The universe is incredibly noisy, packed with random solar interference, human military radar, and exotic stellar phenomena that can easily mislead even the most careful and experienced observers. Despite that lack of confirmation, that fleeting 72-second burst continues to occupy a legendary place in the human imagination, because it perfectly captured the intense tension of our isolation. It was not absolute proof of an alien neighbour, but it was a dazzling flash of pure possibility. For just over a minute, the silent sky seemed to speak in a voice that was completely unusual, before falling entirely quiet once more and leaving humanity to listen even harder into the dark. This patient, ongoing vigilance is what makes newly discovered planetary systems like TRAPPIST-1 so deeply exciting to explore. This incredible system packs 7 distinct, rocky worlds tightly around a single miniature star. That compact arrangement alone makes the entire solar system feel almost physically impossible, resembling a highly organized collection of miniature planets tucked closely around a faint, glowing red ember. The central star of TRAPPIST-1 is significantly smaller, dimmer, and cooler than our own bright yellow sun. Yet it acts as the gravitational anchor for 7 individual worlds that are all roughly the same size as Earth, all crowded into an orbital space that is tighter than the orbit of Mercury in our own neighbourhood. If you were to travel there and stand on the surface of one of the outer planets in that system, looking up at the sky would reveal an absolutely breathtaking sight. Because the planets are nestled so incredibly close together, your neighbouring sister worlds would not appear as tiny, indistinguishable points of light like Mars or Venus do from our vantage point on Earth. Instead, they would hang immense and detailed in your local sky, appearing as giant visible globes drifting slowly past. Complete with visible crescent phases, swirling cloud decks, and recognizable geographical features. Their orbital periods are incredibly fast, with some worlds completing an entire planetary year in just a handful of days. What makes this system so thoroughly captivating to the human mind is not just the sheer number of planets, but their deep cosmic intimacy. This is not a story of finding one lonely, isolated candidate for life lost in the vastness of space. It is an entire architecture of possibility built around a single star. Nature did not merely construct one intriguing world in that system, it crafted an interconnected chain of them, almost daring humanity to reach out, study each one, and discover which world holds the ultimate secret. The scientific excitement reached a peak when astronomers realized that exactly 3 of these packed TRAPPIST-1 worlds sit directly inside the star's habitable zone. This precise detail is why the system completely captured the global imagination so rapidly. Out of those 7 crowded worlds, 3 orbit at the exact distances where planetary temperatures could easily allow liquid water to pool and stream across the surface, provided they possess the proper atmospheric blankets. That specific phrase, the right atmosphere, matters immensely in modern astrobiology. A planet can sit in the absolute perfect orbital position, But if its sky is completely stripped bare by stellar radiation, or if it is smothered by a runaway greenhouse effect, the surface will remain completely hostile and dry. This realization transforms the atmosphere from a simple background feature into the primary engine of a planet's habitability. The thin veil of gases wrapping around a world is a dynamic, living system that regulates heat, shields against deadly cosmic rays, and provides the essential chemical pressure needed for liquid oceans to exist. When we study these distant skies, we are looking at the ultimate protective shield. Without a stable atmosphere, the most promising rocky world is reduced to a barren, frozen desert. That is why our newest space observatories, like the James Webb Space Telescope, are focusing their immense mirrors on the TRAPPIST-1 system, attempting to peer through the glare of the red dwarf star to read the chemical secrets hidden within the air of those three temperate worlds. We are searching for signs of clouds, weather, and thermal stability that could turn a rocky sphere into a genuine home. To achieve this incredible feat, telescopes like the James Webb utilize a brilliant technique that depends on the precise alignment of cosmic orbits. When a planet passes directly between its host star and our vantage point in space, a tiny portion of the starlight slips cleanly through the planet's atmosphere before travelling across the light years to reach our mirrors. That atmospheric rim may look like a thin microscopic veil, but it leaves an undeniable chemical fingerprint embedded within the starlight. Because different chemical gases naturally block and absorb very specific wavelengths of light, the starlight arrives at our sensors subtly altered by its passage through the alien sky. The highly sensitive instruments on board the Webb telescope can measure these microscopic changes in colour and infer exactly what molecules are present in that distant air. It is an almost unbelievable triumph of human ingenuity. A telescope floating 1 million miles away from Earth can detect the faint signatures of water vapour, methane, carbon dioxide, and other vital compounds wrapped around a world located light years deep in the cosmic ocean. Nothing about this scientific process is visually loud or dramatic. There is no glowing alien city skyline appearing on our screens, and there are no immediate cinematic revelations. There is only the collection of exquisite measurements, the tracking of data plots, and the patient, disciplined interpretation of light graphs. Yet the final result feels absolutely magical anyway. Human beings are actively reading the complex chemistry of completely unreachable skies without ever leaving our local orbit. Through the power of filtered starlight alone, worlds that once seemed completely isolated and unknowable are beginning to tell us exactly what fills the air above their hidden landscapes. As we look to the future, even more advanced space telescopes are being designed to spot Earth-like worlds by completely blocking out the overwhelming light of their home stars. One of the single greatest technical hurdles in modern exoplanet astronomy is that stars are incredibly bright, drowning out their tiny planetary companions in a brilliant wash of light. Trying to see a small, rocky planet next to a burning star is like trying to photograph a tiny firefly buzzing right next to a massive, industrial searchlight from miles away. To overcome this obstacle, scientists are developing specialized instruments called coronagraphs, as well as giant, flower-shaped orbital shields known as star shades that will launch into space and position themselves thousands of miles ahead of a telescope. By perfectly aligning the starshade to block the direct glare of the star, the telescope will finally be able to look around the edges of the darkness and capture the faint, direct light reflecting off the planet itself. When this technology is fully realized, we will no longer be relying solely on indirect shadows and transits. We will be looking directly at the planets themselves, capturing the independent glint of alien oceans, the seasonal shift of continents, and the true colours of distant worlds. This direct imaging will allow us to analyse the atmospheres of Earth-sized planets, with unprecedented precision, turning the vague possibilities of today into the definitive maps of tomorrow. Yet, as our technology grows increasingly sophisticated, it forces us to confront a profound and slightly unsettling philosophical possibility. The universe may prefer microbes over minds almost everywhere you go. When we look honestly at the history of our own planet, microbial life arrived incredibly early, showing up in the oceans almost as soon as the surface cooled down, and dominating the biosphere completely for billions of years. In sharp contrast, complex multicellular animals, land plants, and advanced tools using intelligence arrived astonishingly late in the script, emerging only after an immense stretch of time and a highly fragile chain of random environmental coincidences and mass extinctions. This stark historical reality suggests something deeply important about the nature of cosmic evolution. The easiest form of life to successfully ignite and permanently persist across the cosmos may be simple, single-celled life. A universe that is absolutely crowded with thriving bacterial biospheres, yet nearly empty of conscious, reflective minds, is not only a distinct possibility, it may actually be the most statistically likely outcome of all. That grand idea can feel slightly disappointing and lonely at first glance, until you pause to realize just how extraordinary and transformative microbial life truly is. A single verified alien microbe would instantly answer the greatest question in human history, proving forever that biology is a natural, universal consequence of chemistry rather than a localized Earth miracle. Entire worlds could be completely reshaped by microbial biospheres, which can alter global oceans, rewrite atmospheric chemistry, and transform the mineral composition of a planet's crust for eons without ever producing a single creature that builds a tool or contemplates the stars. If this turns out to be the common reality across space, then our galaxy may be incredibly rich with biological life while remaining completely quiet on our technological instruments. The Milky Way could be teeming with complex metabolism, rapid adaptation, and endless microscopic evolution occurring across trillions of small scales, yet rarely ever crossing the difficult threshold into high intelligence. Life itself may be a common cosmic feature, but minds like ours, capable of building radio telescopes and questioning our own existence, may be an unusual, highly exceptional flourish rather than the standard rule of the universe. This possibility follows naturally from everything that the history of the Earth tries to teach us. Single-celled life seems to arise relatively easily whenever the raw chemical ingredients and a steady energy source are present together. However, the transition to complex, multicellular organisms appears to require a long, incredibly demanding checklist of additional developments. It demands perfectly stable planetary environments over immense periods, highly energetic cellular metabolisms like those provided by oxygen respiration, major evolutionary innovations, and perhaps an extraordinary amount of sheer luck. On our own home planet, it took billions of years for simple cells to figure out how to cooperate and form complex bodies. This was not a fast, smooth, or inevitable transition. Therefore, a galaxy packed with living worlds might still contain very few environments that host animals, forests, or anything remotely comparable in physical complexity. Many planets could easily remain entirely microbial for their entire multi-billion-year histories, not because they failed or got stuck, but because simple life is remarkably robust, completely sufficient, and perfectly adapted to its world. This profound thought gently changes the entire emotional shape of our search, reminding us to appreciate the immense wonder of life in any form it chooses to take, no matter how small. This realization completely changes the emotional and philosophical undertone of our ongoing cosmic vigil. It gently encourages us to look at the massive starfields above our heads not as a loud, crowded stadium waiting to shout back at us, but as a vast, quiet nursery where simple organisms are patiently growing in the dark. If the entire galaxy is predominantly filled with these silent, single-celled ecosystems, then our current failure to intercept artificial radio broadcasts makes perfect logical sense. We are scanning the heavens for sophisticated technology when we should instead be looking for the faint microscopic signatures of basic metabolism. This shifts our cosmic perspective from an anxious desire for conversation to a calm, disciplined appreciation of raw presence. The universe is not empty or dead just because it refuses to speak to us in our native tongue. It may simply be resting in an earlier, more peaceful phase of its natural evolutionary cycle, moving slowly through its epochs without any urgent pressure to develop minds like ours. To fully explore this massive landscape of quiet biology, we must continuously invent brand new scientific methods to look closely at things that sit entirely beyond our normal field of vision. One of the absolute most peaceful and elegant fields of modern science involves looking at the raw molecular dust clouds that drift silently through the deep, empty spaces between different solar systems. These giant clouds, known as interstellar molecular clouds, are often light years across, forming soft, glowing nebulae that look like massive, colourful brushstrokes painted directly onto the black velvet fabric of space. For a very long time, early stargazers assumed these dark clouds were completely empty voids, absolute pockets of nothingness, where the light from distant stars was simply blocked from view. However, when we developed advanced radio and infrared telescopes that could peer directly through the thick dust, we discovered a completely different reality. These cold, quiet molecular clouds are actually the primary chemical laboratories of the grand cosmos. Deep inside their freezing interiors, where temperatures hover just a few degrees above absolute zero, atoms of hydrogen, carbon, nitrogen, oxygen and sulfur are continuously moving at a remarkably slow, deliberate pace. Because the environment is so incredibly cold and protected from the harsh radiation of open space, these individual atoms can gently bump into one another and form stable chemical bonds. Over immense stretches of time, this slow cosmic dance generates a truly astonishing variety of complex organic molecules. Astronomers scanning these beautiful dust clouds have successfully detected the clear, undeniable barcodes of complex sugars, alcohols, formaldehyde, and even basic amino acids, the absolute structural building blocks that are used to assemble proteins and DNA inside living Earth organisms. This means that the essential raw ingredients for biological life are not rare exotic treasures that are uniquely manufactured on lucky planetary surfaces like Earth. Instead, they are an incredibly common natural consequence of fundamental cosmic chemistry, generated in massive abundance inside the freezing voids of open space long before any planets are even born. When a new star system slowly forms inside one of these nebulae, gravity pulls the gas and dust together to form a central sun and a surrounding disk of planets and comets. The newly forming worlds are literally drenched from the very beginning in a rich organic soup provided by the birthplace cloud. Comets and icy asteroids act as natural delivery trucks, carrying these space-borne organic molecules across the solar system and dropping them softly onto the surfaces of young planets. This beautiful realization tells us that the spark of life is permanently written into the basic rule book of the universe, waiting quietly in the dust to find a warm, wet place to grow. As you contemplate these vast organic clouds drifting silently through the galaxy, let your mind relax into the steady, peaceful rhythms of cosmic creation. There is no urgency in the way a nebula forms a star, and there is no rush in the way atoms build molecules in the deep cold. Everything takes place across millions and billions of years, operating on a timeline that makes our hurried human schedule seem completely insignificant. By allowing ourselves to sync up with these massive, slow-moving cosmic timelines, we can find a deep sense of internal stillness, realizing that we are part of a grand, orderly process that has been unfolding with absolute patience since the dawn of time. This deep appreciation for the chemistry of open space helps us understand why scientists are so profoundly fascinated by looking at comets and primitive asteroids up close. These small, icy bodies are essentially pristine time capsules holding the exact, unaltered chemical ingredients that existed at the very birth of our solar system over 4.5 billion years ago. While the giant planets have constantly churned their materials through intense heat, volcanic activity, and atmospheric pressure, comets have spent the last few eons parked in the deep freeze of the outer solar system, preserving their ancient structures in absolute perfection. When a comet occasionally falls inward toward the Sun, the increasing solar warmth causes its ancient ice to sublimate, creating a spectacular, glowing atmosphere and a long, magnificent tail of gas and dust that streams across millions of miles of space. When our advanced space probes executed daring missions to fly directly into these glowing cometary atmospheres, they captured spectacular data that completely confirmed our models of cosmic chemistry. The instruments detected a complex abundance of organic materials, including glycine, the simplest amino acid used by living organisms to construct proteins. This physical discovery provided the ultimate material link between the open chemistry of interstellar space and the biology of our planet. It proved that the exact molecules that initially stirred in our ancient oceans to form the very first living cells were originally forged in the cold darkness of a molecular nebula, carried across space inside frozen comets, and delivered gently to the early Earth. We are not separate from the rest of the cosmos. Our very bodies are constructed out of ancient stardust and interstellar ice that has travelled across the galaxy to find a temporary home in us. This profound chemical unity suggests that the exact same delivery system has been operating with absolute consistency around trillions of other stars throughout the history of the universe. Every single planet orbiting in a distant Goldilocks zone has likely received the exact same organic care package from its native molecular cloud, packed with the same collection of sugars, amino acids, and water ice. The raw potential for life is scattered across the galaxy like seeds waiting for the right spring rain. Whether those seeds successfully sprout depends entirely on the unique local conditions of the world they land on, but the seeds themselves are always there, drifting quietly through the dark, ensuring that the universe is permanently alive with pure, unspoken possibility. As we look deeper into this cosmic tapestry, we must also appreciate the beautifully quiet and peaceful role that gravity plays in shaping these planetary nurseries. We often think of gravity as a violent, destructive force that crushes stars, powers cataclysmic black holes, and drives massive planetary collisions. But in our day-to-day lives and across the stable solar systems of the galaxy, gravity operates as a remarkably gentle, reassuring custodian. It is the silent, invisible hand that keeps our oceans pinned softly to the crust, ensures our atmosphere stays wrapped comfortably around our shoulders, and guides our planet along a smooth, predictable path around the Sun year after year. Gravity provides the ultimate structural predictability that allows life to rest, recover, and slowly evolve without fear of flying off into the cold void. This gentle gravitational stability is particularly beautiful when we study the complex choreography of moons orbiting around the outer gas giants. Take a moment to visualize the planet Saturn, surrounded by its magnificent spinning architecture of rings and its diverse family of over 80 individual moons. Each moon moves along its own precise, calculated path, executing an endless cosmic ballet that has been running without a single interruption for billions of years. The smaller moons, often just a few miles across, act as natural shepherds for the rings, utilizing their subtle gravitational pulls to cleanly steer the ice particles, maintain the sharp edges of the gaps, and keep the entire ring system from dispersing into open space. It is a display of absolute order and balance, a quiet mechanical harmony that runs perfectly on its own without any need for human oversight or maintenance. Among this large family of Saturnian worlds, the massive moon Titan stands as one of the absolute most peaceful and intriguing environments in the entire solar system. Titan is the only moon in the cosmos that possesses a dense, substantial atmosphere, wrapping the entire world in a thick, permanent shroud of soft orange haze. The atmospheric pressure on Titan's surface is actually slightly higher than the air pressure we experience on Earth, creating a cozy, heavy blanket of nitrogen and methane gas that completely shields the landscape from the harsh conditions of open space. Because it sits so incredibly far from the Sun, the surface of Titan is intensely cold, hovering around -300 degrees Fahrenheit, which completely changes the way ordinary materials behave. At these extreme temperatures, water ice freezes so completely solid that it loses its slippery quality and behaves exactly like hard silicate rock, forming massive, frozen mountains and craggy valleys that shape the moon's geography. But the most truly miraculous feature of Titan is that it is the only other world in the entire universe known to possess stable, liquid liquids pooling openly on its surface. Because the temperature is just right for methane and ethane gas to condense into liquid form, Titan features a complete, active hydrological cycle that perfectly mirrors the water cycle of Earth, but utilizes liquid hydrocarbons instead of liquid water. Imagine resting on the shores of Kraken Mare, the largest sea on Titan, located near the moon's north pole. The landscape around you is completely tranquil and still, shrouded in a permanent soft orange twilight that filters through the thick nitrogen sky. Because Titan's gravity is significantly weaker than Earth's, and its atmosphere is vastly denser, any liquid waves moving across the sea travel at a remarkably slow, luxurious pace, rising to gentle heights and rolling softly against the frozen ice shores with a deep, muffled sound. The liquid methane is completely clear and smooth, reflecting the dim amber glow of the sky like a giant, unmoving mirror. Occasionally, a gentle, slow-moving drizzle of liquid methane raindrops falls from the orange clouds above, floating down through the thick air like tiny flakes of snow before joining the peaceful sea below. This liquid hydrocarbon environment represents a completely separate paradigm for potential astrobiology, challenging our traditional assumption that liquid water is the absolute only medium through which life can emerge. While water is a highly polar solvent that excels at dissolving specific types of chemicals, liquid methane is a non-polar solvent that could theoretically host an entirely different system of biochemistry. Visionary astrobiologists have designed complex theoretical models of cellular membranes, genetic codes, and metabolic pathways that could operate flawlessly inside liquid methane, utilizing entirely unique combinations of nitrogen, carbon, and hydrogen molecules to store information and process energy. If life has successfully found a way to ignite inside the freezing seas of Titan, it would represent a completely independent genesis of biology, proving that the universe is not limited to a single chemical formula for awareness. As you allow your mind to wander across the orange plains and quiet seas of Titan, let the deep, unhurried stillness of that world settle into your own thoughts. Out there, millions of miles away, that beautiful alien landscape is existing in absolute peace right now, completely untouched by the noise and frantic pace of our human civilization. The clear methane seas are rippling softly in the dim light, the frozen mountains are standing strong against the cold, and the thick atmosphere is cradling the entire world in a permanent, protective embrace. There is an immense, profound comfort in knowing that such deep serenity exists out in the dark, serving as a quiet reminder that our universe is a vast sanctuary of peaceful, hidden wonders. That famous disappearance is everything to us. If that unique transmission had only repeated itself a few more times, the remarkable story might have already completely transformed modern astronomy and rewritten our textbooks forever. If it had been clearly explained away by a simple mechanical error or a passing piece of space junk, it would have long ago faded away into a tiny forgotten historical footnote. Instead, it continues to hang endlessly in the awkward, uneasy space between those two clean outcomes. It remains far too striking to ever completely wipe from our thoughts, yet it remains far too brief to ever truly trust as absolute fact. This fascinating tension is what keeps the mystery alive, an unresolved question mark that reminds us of just how fragile our early attempts to observe the broader universe truly are. This realization is precisely why the patient observation of highly structured systems like TRAPPIST-1 provides such a beautiful sense of hope. When we look closely at this marvelous collection of worlds, we are looking at an environment where a planet with too much water may become something completely different from our familiar Earth, and not always in a helpful way for the long-term development of complex life. At first glance, a distant planet completely covered in liquid water sounds like the ultimate dream of astrobiology. Water is celebrated almost everywhere as life's most precious and necessary ingredient, so it seems completely logical to assume that having more of it would automatically be better. But if nature builds an ocean world with too much water, it can inadvertently smother the very possibilities it was trying to create. When a planet features an ocean that is hundreds of miles deep, completely covering every single piece of solid land, it removes the dynamic relationship between dry rock, shallow shores, and open atmosphere that proved so vital for early life on our own world. On Earth, our continents act as giant chemical factories, weathering down under the rainfall to dump precious minerals, nutrients, and iron into the coastal waters where simple organisms can easily harvest them. Remove the continents entirely, and the whole character of the planet changes in a flash. Without land to break up the flow, global winds would race across completely uninterrupted seas, building up massive, terrifying storms that gather intense energy over thousands of miles. The delicate chemistry of the deep ocean would control absolutely everything, transforming the entire planet into a uniform, hyper-pressured environment where change happens at an incredibly slow and predictable pace. Some of these massive aquatic worlds may carry water layers so incredibly immense that the sheer weight of the ocean above creates exotic, high-pressure ice at the very bottom. This physical phenomenon effectively seals the liquid ocean off from the rocky mantle below. This creates a deep barrier that blocks the flow of hot volcanic vents and vital chemical nutrients, cutting off the exact source of energetic food that many scientists believe is required to spark life in the dark. It is a profound cosmic paradox. A planet can easily have too much of a good thing, turning a potential cradle of life into a sterile, beautiful water prison. This deep structural complexity is exactly why our thoughts are so frequently pulled toward the strange environments created by red dwarf stars. Because these miniature suns are so small and faint, any planet orbiting within their habitable zones must huddle incredibly close to the stellar surface to absorb enough warmth to keep its water liquid. This extreme physical proximity creates a powerful gravitational lock known as tidal synchronization, where the planet is forced to rotate on its axis at the exact same speed that it orbits its sun. This creates a permanent day side and a permanent night side that never change places. One half of the world is doomed to endure constant, unblinking starlight, while the other side sits forever in cold, frozen darkness. At first glance, that sounds like the absolute end of habitability. You easily imagine one hemisphere completely scorched into a dead cracked desert, while the opposite side is buried under a mountain of permanent ice. But when complex atmospheric models are run through modern supercomputers, a much more interesting and peaceful possibility begins to emerge. If a tidally locked planet possesses a thick enough blanket of air, the natural physics of heat distribution will set up a massive, continuous global wind system that acts like a planet-wide air conditioner. The intense heat absorbed by the day side will naturally rise and rush toward the dark side, while the freezing air from the night side will stream back along the surface to cool the illuminated hemisphere. This constant global circulation can create a stable, permanent ring of temperate conditions right along the border between light and shadow. This narrow band of twilight, often called the Terminator line, could host a remarkably peaceful and unchanging environment. In this golden ring, the alien sun would hang forever pinned right at the horizon, never rising higher and never setting below the edge of the world. The landscape would be washed in a permanent soft amber sunset that lasts for billions of years without a single interruption. For any life form evolving within this narrow twilight strip, the concept of a regular day and night cycle would be completely non-existent. Time would not be measured by the movement of the sun across the sky, but by the slow, steady patterns of global weather, creating a world of absolute unhurried predictability. Under these faint red dwarf stars, photosynthetic organisms would have to evolve completely different survival strategies than the green plants we find on Earth. Because red dwarfs emit most of their energy in the infrared and near-infrared spectrum, an alien forest growing on a tidally locked world would look deeply unfamiliar to human eyes. To capture the maximum amount of this low-energy light, the leaves and structures of these organisms might adapt by turning a deep, rich black or a dark, velvety purple. Their entire world could look significantly darker, stranger, and shifted in ways that we do not instinctively expect based on our local experience. This is one of the primary reasons exoplanet astronomy is so deeply humbling. It forces us to stretch our imaginations past the comfortable boundaries of our home planet and accept that nature has an almost infinite palette of designs. This search for life forces us to realize that we are hunting not just for familiar chemical substances, but for a deep sense of order written into distant worlds from very far away. We are looking for patterns that cannot be explained by the random, messy processes of geology or stellar physics alone. This is precisely what the James Webb Space Telescope is actively doing right now, turning these abstract philosophical questions into cold, hard data. For decades, the search for life beyond Earth lived partly in the realm of future promises, a distant goal that always seemed to belong to the next generation of researchers. But the moment Webb's massive golden mirror opened in space, that promise finally became a real reality. Webb is already examining real alien atmospheres with a level of precision that once sounded completely impossible to achieve. This is what makes our current historical moment feel so uniquely thrilling. We are no longer merely listing interesting planets on a digital chart and hoping that someday in the distant future we might build an instrument capable of studying them properly. We are actively beginning to test what their skies are made of, chemical layer by chemical layer. Webb can look for specific gases tied directly to climate stability, water vapor retention, and active chemistry that shapes whether a world could support a living biosphere. It is true that our modern instruments are not yet reading detailed alien weather reports line by line, and they are not handing us definitive proof of complex biology. But they are successfully transforming distant planets from vague, hopeful points of light into real physical places with measurable air. That conceptual shift matters deeply to the human story. A candidate world stops being a speculative dot on a spreadsheet and starts becoming a genuine environment with its own unique history and character. For the first time in our long existence, humanity has an instrument that can truly begin interrogating the atmospheres of other worlds, turning the silent sky into a collection of readable pages. When we look honestly at the history of our own planet to guide this search, we are reminded of a powerful fact. For the vast majority of its long existence, the Earth was entirely microbial. Tiny, single-celled organisms ruled this planet completely for billions of years long before animals, massive forests, or human intelligence ever arrived on the scene. This suggests that the first life we successfully find elsewhere, if we manage to find it at all, is far more likely to be microscopic and subtle, rather than dramatic and obvious. It may form thin, sticky films on wet rocks, drift quietly in underground water tables, or survive as sparse, lonely communities in incredibly harsh, radioactive environments. To human eyes, looking for dramatic signs of life, a universe filled with microbes might seem almost disappointingly plain at first glance. We want to see vast alien cities, alien forests, or complex creatures swimming through alien seas. Yet, if we can find even a single alien microbe, it would instantly become one of the greatest and most transformative discoveries in the entire history of human thought. A few simple cells surviving on a distant rock would prove once and for all that biology is not a unique, miraculous fluke confined exclusively to Earth. They would tell us that the universe can naturally take basic chemistry and shape it into life anywhere the conditions are just right. This means that the first alien life may therefore enter human knowledge as evidence before appearance, as a slow, measurable process before a clear portrait, and as a mathematical certainty without a physical face attached to it. We must prepare ourselves for a scientific discovery that unfolds through peer-reviewed papers and data graphs rather than dramatic television broadcasts. We might know with absolute certainty that something is living and breathing on a distant world without having any idea what the physical organism actually looks like. That kind of discovery would still be profoundly beautiful. It would tell us that living processes are actively at work elsewhere in the dark, even if the physical body behind them remains completely hidden from our visual lenses for centuries to come. The absolute hardest part of this entire process may be proving a genuine miracle to cautious, skeptical scientists. That phrase sounds slightly dramatic, but it captures a very real and demanding challenge within the scientific community. A detection of life beyond Earth would be so immensely important, carrying such massive philosophical weight that no serious researcher would ever want to accept it lightly or rush to a conclusion. Every single instrument used to capture the data would be questioned down to its very screws. Every possible source of local contamination would be exhaustively considered. Every non-living chemical explanation would be tested as hard as physically possible before anyone dares to utter the word life. This extreme caution is not cynicism or a lack of imagination. It is the absolute foundation of real science. The more important a discovery is, the higher the standard of proof must be to support it. Scientists will push against their own discoveries with relentless skepticism because they want the truth to be completely bulletproof. They know that a false alarm would damage the credibility of the entire search, misleading the public and obscuring the real path to understanding. Therefore, the day we find life will not be a day of sudden, wild celebration, but the beginning of a long, rigorous, and incredibly intense period of verification, where the universe is asked to prove its secrets over and over again until no doubt remains. When we realize that an absolute determination of alien biological processes demands a truly monumental standard of physical verification, we can easily look out at our vast night skies with a renewed sense of patience and tranquil wonder. we begin to understand that the slow, methodical pace of modern scientific analysis perfectly mirrors the calm, gradual ways in which the broader universe constructs its marvellous planets over billions of years. Out there in the great quiet of deep space, there are no rushed timelines, and there are absolutely no frantic struggles to instantly prove a theoretical hypothesis to an impatient audience. Everything unfolds exactly when the fundamental laws of chemistry and physics dictate it must. This realization means that our collective search for hidden alien ecosystems is not just a straightforward race against time to capture a sudden flashy headline on a morning news broadcast. Instead, it operates as a deeply profound, multi-generational journey of listening quietly to the faintest energetic signals crossing the dark void. As you sit back, relax completely, and allow your thoughts to comfortably drift alongside these deep concepts, consider the peaceful landscapes of our own solar system's outer frontier. Far beyond the warm, familiar light of the inner rocky planets, the ringed planet Saturn holds on to its own massive collection of icy mysteries, serving as an absolute masterclass in structural harmony. If we focus our attention directly on the large moon Titan, we find ourselves observing a world that acts as a marvellous mirror image of our early Earth, but constructed out of completely different physical materials under extreme conditions of freezing cold. The thick, permanent orange sky wrapping around Titan behaves like a soft, heavy blanket that entirely insulates the landscape below from the violent radioactive forces of open space. The atmospheric pressure walking across its surface is remarkably close to what our bodies feel at the bottom of our own air ocean, offering a cozy sense of familiarity in an environment that is sitting millions of miles away from our home. Down on that frozen surface, the unbelievable cold completely alters the standard properties of the things we interact with daily. Common water ice is frozen so intensely hard that it completely loses its classic liquid and slippery qualities, transforming instead into a tough, solid geological bedrock that forms towering mountains, jagged cliff faces, and deep, winding river systems. But instead of flowing with liquid water, the active weather cycle on Titan utilizes liquid methane and ethane to carve its pathways across the frozen terrain. This creates an incredibly beautiful alternative hydrological cycle where clouds of organic gas condense in the upper atmosphere, forming gentle, slow-moving raindrops that float softly through the dense nitrogen air before pooling into vast, serene lakes and global seas. Imagine standing quietly on the completely silent shores of a methane sea near Titan's North Pole. The entire world around you sits in a state of absolute unmoving serenity, washed in a permanent dim orange twilight that gently filters through the thick hydrocarbon haze above. Because the moon's gravity is significantly weaker than what we experience on Earth, any liquid waves travelling across the surface of the sea move at a remarkably slow, luxurious pace, rising into smooth, fluid crests before rolling softly against the rock-hard ice shores with a muffled, rhythmic sound. The clear liquid hydrocarbons are so perfectly smooth that they reflect the glowing amber sky like a giant, unhurried mirror stretching across the horizon. There are no sudden disruptions, no chaotic storms, and no frantic movements to break the stillness. There is only the slow, eternal cycle of methane rain feeding the clear seas, existing in absolute peace, completely independent of human awareness. This unique landscape provides astrobiologists with a spectacular, alternative model for how life might potentially ignite and survive without relying on liquid water at all. While water is universally celebrated as a highly polar solvent that excels at facilitating specific biological reactions, liquid methane functions as a non-polar medium that could theoretically support a completely distinct style of organic biochemistry. Creative researchers have successfully developed detailed theoretical maps showing how alien cellular membranes, alternative genetic codes, and unique metabolic pathways could operate flawlessly inside these freezing liquid seas, utilizing unique combinations of carbon, hydrogen, and nitrogen to gather energy and pass on genetic information. If primitive organisms have successfully crossed the threshold into living systems within the dark waters of Titan, it would prove that nature is not limited to a single localized recipe for creating awareness, completely transforming our understanding of biology's true potential. By allowing your conscious mind to gently rest upon the orange plains and quiet hydrocarbon oceans of Titan, you can permit the heavy, frantic weight of your everyday human worries to gently dissolve into the immense distances of the outer solar system. Out there right now, this beautiful, serene world is executing its slow orbits around Saturn in absolute stillness, entirely unbothered by the noisy schedules and complex anxieties of our terrestrial lives. The clear seas are rippling softly in the dim amber light, the frozen mountains are standing strong against the cold, and the thick atmosphere is cradling the entire landscape in a permanent protective embrace. There is a deep, profound comfort in realizing that such absolute serenity is actively taking place across the cosmos, serving as a quiet reminder that our universe is a vast, beautiful sanctuary of peaceful wonders. This perspective naturally encourages us to look past our local neighborhood and contemplate the truly immense collection of stars that form the wider galaxy. As our advanced space telescopes continuously scan the deep dark, cataloguing thousands of new worlds orbiting distant suns, they are revealing that the cosmos is a literal tapestry of endless possibilities. Every single star system we observe features its own unique gravitational dance, its own specific chemical blend, and its own unique story of creation unfolding across millions of years. The sheer scale of this galactic landscape can easily feel completely overwhelming to the human mind, until you realize that this vastness is not a cold, empty void, but a limitless canvas where the laws of nature are constantly working to build order out of chaos. When we study the formation of these distant worlds, we learn that they are deeply connected to the massive molecular clouds that drift silently through the empty spaces between the stars. These giant clouds of gas and dust, stretching across light years of space, serve as the ultimate cosmic nurseries where new suns and planetary systems are continually born. Deep inside their freezing interiors, protected from the harsh radiation of open space, individual atoms of hydrogen, carbon, oxygen, and nitrogen move at a remarkably slow, deliberate pace, gently bumping into one another to form stable chemical bonds over eons. This patient molecular assembly line generates a stunning variety of complex organic compounds, ensuring that the fundamental building blocks of life are scattered in massive abundance throughout the galaxy long before a single planet even finishes forming. When a young planet finally stabilizes within the temperate zone of its host star, it inherits this rich chemical legacy directly from its birthplace cloud, receiving a treasure package of water ice, organic molecules, and essential minerals delivered gently by passing comets and asteroids. The raw ingredients for biology are everywhere, floating silently in the dust and ice, waiting patiently for the right local conditions to spark them into active growth. This magnificent realization tells us that the entire universe is permanently alive with unspoken potential, moving slowly and orderly through its vast epochs without any urgent rush, allowing life to awaken in its own time across the peaceful reaches of the cosmic ocean. This beautiful cosmic delivery mechanism helps us understand why contemporary researchers spend so much time studying the deep, untouched spaces of our own outer planetary neighborhood. When we direct our focus back toward the giant gas planets, we are frequently reminded that the universe builds magnificent, stable sanctuaries where physical cycles operate with perfect, clockwork predictability over immense stretches of time. Every single moon orbiting a giant planet like Saturn or Jupiter moves along an elegantly carved orbital pathway, executing an endless celestial dance that has been running without a single structural error for billions of years. This mechanical perfection provides the ultimate background stability required for complex chemistry to slowly mature, illustrating that nature is completely comfortable working across luxurious timelines to achieve its goals. As you allow yourself to sink deeper into a state of total, soothing relaxation, let your thoughts rest comfortably upon the grand, icy plains of the moon Enceladus. Out there in the dark, this tiny, brilliant white world continues to perform its regular orbital loops around Saturn, silently launching its massive glittering fountains of subsurface ocean water high into the vacuum of open space. The internal geothermal engines driving these eruptions run completely on their own, powered by the steady, unyielding gravitational pull of the massive ringed planet nearby. There is absolutely no noise, no frantic struggle, and no artificial pressure guiding these grand cosmic plumes. They simply emerge from deep fractures in the thick ice crust, scattering ice crystals and essential organic compounds into the quiet void, completely independent of human observation or worry. By aligning your mind with these slow, majestic orbital movements, you can easily permit the frantic anxieties of your everyday life to softly slip away into the deep spaces between the worlds. There is a profound healing comfort in realizing that such absolute serenity and order exist completely on their own out in the stellar dark. The glistening fountains of Enceladus are rising and falling right now in perfect stillness, the vast sheets of hard water ice are standing strong against the cold, and the entire cosmic system is operating with absolute, unhurried grace. We belong to a reality that is infinitely grander and more peaceful than the small momentary challenges we encounter in our daily schedules. This deep sense of planetary harmony naturally encourages us to turn our curiosity toward the vast populations of exoplanets that populate the more distant corners of our galaxy. With every passing year, our advanced space observatories detect more rocky worlds nesting safely within the temperate Goldilocks zones of their respective host stars. These discoveries continuously prove that our universe is a literal paradise of variety, packed with an endless assortment of planetary environments where life could theoretically find a unique pathway to emerge. Some of these far-off worlds may feature massive global oceans that run completely uninterrupted by continents, where water chemistry rules over every single geological mechanism. Other systems might hold tidally locked worlds pinned under the permanent amber glow of a gentle red dwarf star, creating beautiful stable strips of eternal twilight along their terminator borders, where biological processes could run continuously for eons. As we map these distant skies layer by layer, using the filtered starlight captured by our latest technology, we are actively rewriting our understanding of our place in the cosmic hierarchy. We are gradually learning that the raw potential for biology is not a rare, localized anomaly reserved exclusively for our home planet, but a fundamental structural feature woven directly into the basic chemistry of the entire galaxy. The universe is a vast, beautiful canvas where organic molecules, steady energy sources, and liquid mediums are constantly coming together to create new possibilities for awareness to spark. Whether those possibilities manifest as humble microbial films hidden deep inside underground aquifers, or as highly complex ecosystems thriving along a permanent sunset ribbon, they all share the exact same cosmic heritage, forged in the cold hearts of ancient molecular nebulae long ago. As the stars above continue to shine with a soft, steady radiance, allow your mind to completely let go of any lingering desire for immediate answers or final conclusions. The great questions of the cosmos, whether we are completely alone in the dark, how life initially bridges the threshold from ordinary chemistry, and what secrets are hidden beneath unreachable alien ice sheets, can simply float freely in your consciousness without needing a definitive resolution tonight. There is nothing you need to fix, nothing you need to solve, and nothing you need to hold on to as you rest. There is only the immense, comforting realization of a vast dark sky filled with trillions of unseen worlds, all moving slowly and quietly through their endless, beautiful orbits in absolute peace.